So we've established over the first week of school that an inverse and a function and its inverse undo each other. So we're given three functions here, and we want to write the inverse of each one. So we're going to start with number one, write the equation down. And what we want to think of is, how did they first build this equation? They started with an x, then it became x to the third, then it became x to the third plus 4. So the inverse goes backwards. How do you go from x to the third plus 4 to x to the third? We take away 4. How do you go from x to the third just to x? We're going to cube root it. So our inverse function, remember the notation is the name of the function to the -1 equals, and then what I'm going to do is x minus 4, and then the next step is this cube root, so then the cube root of all of that. Okay, for number 2, to first get this function, what they did is they said, okay, we have an x, and then it became x plus 5, and then we put 3 over the x plus 5. So going backwards, that is going to be the numerator of 3 over an x, and then to go here, we're going to subtract 5. So the inverse of f is 3 over x minus 5. The reason we can just do 3 over x here is on the prior lesson we looked at rational functions like this and like this, and we said that the rational function was the inverse of itself. If we take a quick look at a graph, the graph was like this and like this. So if we reflected it over the line y equals x, it was already a reflection, so the inverse and the function were the same. And last but not least, for number 3, first we started with an x, then we square root it, then it became 6 times that, and then it became minus 7. So now going backwards, we're going to add 7. To go here, we're going to divide by 6. And to go here, we're going to square it. So then that makes our G inverse going to be x plus 7 divided by 6, all of that squared. And if we look in the beginning for number 3, we start with a square root. And we've talked about you cannot square root numbers that are less than 0. So to start, x had to be greater than or equal to 0. That means for the inverse, even though it's quadratic, we have to include the restriction that x has to be greater than or equal to 0, because the original function started with that restriction, so then the inverse also has to have that restriction. Okay, so this page is in your packet. Please find it. We'll pause the video here for you to find it. And now what we're going to have to do is, it tells us the year and the number of households in the thousands that exist. So what we have to find is a linear function that models the number of households. So just like we did with the Celsius and the Fahrenheit problem, we're going to write a linear equation, y equals mx plus b. Because they're giving us years, I'm going to say this is time 0, this is time 1, this is 2 years later, 3, 4, 5, and 6. So when I go to find my b, that's this value, because that's when time is 0. But now we need to find slope. So let's just use the smaller numbers. We can use this coordinate and we can use this coordinate. So we're going to do y2 minus y1 over x2 minus x1. And that gives us 1,883 households per year. So to write my equation, that's going to be y equals 1883x plus 97,107. So now write the inverse. Oh, I should use their function h and t, so I'm sorry I didn't use the appropriate notation. So this is h equals 1883t plus 97107. So now what we're going to do is find the inverse of that. So I'll do part B right here. So to write our equation, first we took t, then we multiplied by the slope, and then we added the y-intercept. So now we're going to go backwards. Oops. All the way to there, and then from there to there. So first we're going to subtract the 97,000, and then we're going to divide by the slope. So that means our inverse function is t minus 97107 divided by 1883. Now find the inverse of 111,000 and interpret your response. So what I'm going to do is take the value of 111,000 and plug that into my h inverse function. And you can use your calculator for this arithmetic. On any non-calculator assessment, we would give you nicer non-calculator numbers, not in the thousands like this. So we get 7.378. So what does that mean? This finds us a year that there were 111,000 households. Well, 7.378 is not a calendar year. We started in 1998. So if we do 1998 plus 7, we are going to get, we are going to get 2005. But because it's 0.378, that's in the year 2005, so we're going to say between 2005 to 2006, there were 111,000 households. So if you turn the page again in your packet, we are going to continue with practicing finding the inverse relation or the inverse function for a given function. And if we scroll down, or halfway down your page, they give us an example. So it says, for each of the following function machines, decide what function can be used to make the output back to the same as the input. Describe it in words and write it symbolically. So here what they give us is they say, okay, Ms. Weiss, your function is x plus 8, and you're going to start with 7. So to go to here, we added 8, we get 15. So then how do we go from here to get back to 7? Well, we're going to subtract 8, because that's what undoes adding 8. So as you can see that their answer, subtract 8 from the result. And here, x minus 8 is their equation. Okay, so now on the next pages you have some problems to practice that with. There are, I think, 9 problems for you to do. So we're going to pause the video here, and let's just do this first page. How many problems? So do the first 3, try them in your groups, and then we will unpause the video and check your answers. Okay, so to go from here to here, they're saying multiply by 3. So then to get back to the output, the opposite will be divide by 3. So my inverse equation is x divided by 3. In words, take the result and divide by 3. Okay, so for number 2, they square it, so that's x squared. So then to undo that, we're going to do the square root. That's the square root of x. In words, take the result and square root it. And lastly on this page is a two-step. First they're saying, so if I'm going to write it out like we did on the warm-up, first what they're saying is take your x, multiply by 2, and then subtract 5. So to go backwards, we're going to add 5 and then divide by 2. So that should give us x plus 5 divided by 2. So let's check that. If we plug in 9, will we get 7? So 9 plus 5 is 14, divided by 2, that is 7. It worked. So in words, you should write take the result, add 5, and then divide by 2. So on the next page, again, try all of these. Try 4, 5, and 6. We'll pause the video here, and then we'll unpause it, and you can check your work. Okay, so for number 4, what happens is, first they're saying, if I look at my equation here, they're saying take x, add 5, and then divide by 3. So going backwards, I'm going to multiply by 3 and then subtract 5. So the inverse function is going to be 3x minus 5. Does that work if we plug in 4 from here? Let's see, 3 times 4 minus 5, 12 minus 5, yep, that's 7. Okay, let's look at number 5. First we had x, and then we subtract 3, and then we square it. So, going backwards, we're going to square root it, and then add 3. So that's going to be the square root of x plus 3. Make sure when you write this that it's very clear that your plus 3 is not underneath the square root. And then last but not least, for number 6, we've got 4 minus root x. Oh, sorry, that's exactly what they gave us. I want to break it apart. Oops. Okay, so first we had, I'm going to rewrite this another way. It's negative x plus 4. If I just switch the order around. So first we had x, then we square rooted it, then we multiplied by negative 1, and then we add 4. So to go backwards, we're going to subtract 4, we're going to multiply by negative 1, and then from here we'll square it. So then that's going to be x minus 4 multiplied by negative 1 squared. So to make that look nicer, I'm going to distribute this x on the inside, and I'm going to say that our inverse is negative x plus 4 squared. Let's just check it to see if we will get that answer. Their result here is 4 minus root 7. So we've got negative of 4 minus root 7 plus 4 squared. This negative has to distribute. That gives us negative 4 plus root 7 plus 4 all squared. Negative 4 plus 4 is 0. So we have root 7 squared, which is 7, which, yippee, that's what we wanted to get. It worked. So our inverse function right here. All right, so now we have a few questions here. 7, 8, and 9 are thinking questions. And take some time with your group members to answer the 3 of these on your paper. And as some sample answers, your answers might vary since they were conversations. But for number 7, the difference between using x and f inverse of x versus always using 7 is if we use x, then that applies to every number we could possibly think of to substitute into either equation. We're not always going to have 7. So by using x, it shows the relationship between the original function and its inverse for any value that you could substitute. In number 4, could any value of x have been used? So number 4 was the original function of x plus 5 divided by 3. So could any value of x been used and still give you the same output for the inverse? Well, the inverse was 3x minus 5. So yes, any value could be used. And the reason that is for this original function, the domain is all real numbers. So is the range. This is technically aligned. We have x over 3 plus 5 over 3. That's aligned. There's no exponents, meaning it's not quadratic or it's not cubic. So because this is aligned, domain and range are all real numbers. Well, if I look at the inverse, that's also aligned. So the domain and range are all real numbers. So any value could be used and you would still get the same input and output. So for number 9, based on your work in this task and other tasks, what relationships do you see between functions and their inverses? So in general, you should have said something along the lines of a function and its inverse undo each other. If you put an input into the function, you get a result and put the result into the inverse. Your output for that is the same original input you started with. Any of those answers would be fine. So now that we're at the end of the classwork, you can use the remaining time in class and you can start this homework in your packet.